In this lesson, we're going to take a look at how to graph the logarithmic functions we've been talking about. And in order to do this, we are going to use a little bit about what we know for exponential equations. So let's take a look at this exponential equation over here just as a warm-up to refresh our memory. So the black graph is our parent graph of 2 to the x power. The purple graph is our function that is going to be our transformed child function. And so if we look at this, a few things that we can see is that it is reflected over the x-axis. The vertical asymptote, or the horizontal asymptote, has moved up to 3. So first thing we know is our child function is going to have a horizontal asymptote at y equals 3. So that would be y equals 2 to the x power plus 3. And then we also need to take a look at whether or not this is moved to the left or the right. So if we look at this point right here at 0, 1, we see that it corresponds with this point right here. So it is moved 1, 2, 3 spaces to the right. So that would have us at x minus 3. We don't need to worry about how much it has moved down because we have already figured out the vertical shift due to the horizontal asymptote. And then we next need to figure out whether or not there is any dilations. We know that there is a reflection over the x-axis, so there's a minus sign out front. And so if we look at this point right here at 3, -1, we can go, to get to the next nice point, we go 2 to the horizontal direction and 4 vertically. So we know that we're going to have a vertical dilation of 4, and then we're going to have a horizontal dilation of 2. So we end up with an equation of that for our child function. And then just as a refresher for our end behavior, what we would have here is as x approaches -infinity, y approaches, in this case, our horizontal asymptote of 3. And as x approaches positive infinity, our y values are headed off to infinity. So what we're going to do is we are going to use the exact same transformation principles that we used in the previous chapters. We're going to use our mapping notation to help us find out the points that are on our child graph. So we're going to do the exact same thing we've been doing. But to make this easy for you, what we need to do is recall the fact that the exponential equations and logarithmic equations are inverses of each other. So in order to help us graph something that is log base 2, we would think about the equation y equals 2 to the x power. So there are 3 points that we are very familiar with. We have 0, 1, 2 to the 0 power is 1. We have 1, 2, and then we have 2, 4, because 2 squared is 4. And you could keep going, 2 cubed is 8 if you want. And so what you need to recall is that the equation of the inverse of 2 to the x is going to be y equals log base 2 of x. And so what we also know about inverses is that if this is the inverse of this, then we know that there are at least 3 or 4 points we know that are on the inverse graph, and that is going to be the inverses of these points. And so we know when we're finding the inverses of these points, we're just going to flip the x and y values. So we have 1, 0, we have 2, 1, we have 4, 2, and if you add one more, we have 8, 3. These points are all on the graph of y equals log 2 to the x power. And we used the information that we know about the parent function y equals 2 to the x power. So in order to graph things like this, let's take a look at this first example. We want to graph this without a calculator and label 3 points and dash in the asymptote. So the parent function of this graph is going to be y equals log base 2 of x. Remember, when you're trying to figure this out, you're going to essentially cross off whatever is not the x and the base. So if you were to cross off everything highlighted in green, you'd be left with log base 2 of x. So we next need to figure out the transformations that are occurring here. One thing that we need to pay attention to is the fact that this says 1/2 x plus 3. So we have to do a little bit of factoring when we see something that is written like this. So if we were to factor out a 1/2, this is really 1/2 x plus 6. So knowing that, we can see that we have a reflection over the x-axis from the minus in front of the 2, in front of the 2. We know we have a dilation, a vertical dilation of scale factor 2. We have a horizontal dilation by a scale factor of 2, because remember, x always lies. So if we're dividing by 2, which is the same as multiplying by 1/2, we're really multiplying by 2. We're moving left 6 and up 1. So if we were going to take all that information and make our mapping notation, what we would have is we would have a reflection over the x-axis. So it would look like this. Our x values are changing. We're multiplying them by 2 and then adding or subtracting 6. And then we are, to our y values, multiplying them by -2 y and then adding 1. So that's going to be our mapping notation. And so next, we would need to figure out what points are on our parent graph. So again, when we do this, we want to think about the equation 2 to the x power, because that's the inverse of log base 2 of x. And so that gives us the points 0, 1, 1, 2, and 2, 4. And so for the inverse parent function, what we're going to have is we're just going to flip them. 1, 0, 2, 1, 4, 2. And then we use our mapping notation just as we have been throughout the whole year. So we have 2 times 1, which is 2, minus 6, that's going to be -4. We have -2 times 0, that's 0, plus 1 is 1. We're going to have 2 times 2, that's 4, minus 6 is -2. And then we're going to have -2 times 1, that gives us -2 plus 1, which is going to be -1. And then we're going to have 2 times 4, which is 8. 8 minus 6 is 2. And then we're going to have -2 times 2, that's -4, plus 1 is -3. So we have our points. So let's put those points on our graph. We have -4, 1, 1, 2, 3, 4, -4, 1, -2, -1, and 2, -3. So we have something that looks like that. We now need to think about where our asymptote is. So we know that logarithms have a asymptote for a parent function at x equals 0. It's the y-axis. So if we're moving 6 units to the left, this is going to be at x equals -6. 0 minus 6 is -6. So our asymptote is going to be at -6, which is right here. So we draw in our asymptote, we make it a dashed line, and then now we're going to sketch in the rest of our graph. It's going to look something like this. There we go. Add in our arrows, and we have our graph, just like that. The domain is going to be -6 to infinity, and then the range is going to be -infinity to infinity. So we have one other example. Why don't you pause the video, attempt it, and then unpause the video, and we'll go over it on the video. So the parent graph here is going to be log base 3 of x. The transformations that are happening here, we have a vertical dilation by a scale factor of 1/2. We are going to have a reflection over y-axis. We're going to have horizontal dilation by scale factor of 2. We're moving left 1 and down 1. So if we're going to write the mapping notation, our mapping notation would be t of xy equals, and then we're going to have a -2x minus 1, and then we're going to have a 1/2 y minus 1. So again, if we think about this, everything's moving to the left 1. This means we're going to have a vertical asymptote at x equals -1. That is because the parent function log base 3 of x has an asymptote at x equals 0, but we're shifting it 1 unit left. So we can figure out our domain and range after we figure all this out. Because we're log base 3, let's think about the graph of 3 to the x power and what points it has. It would have 0, 1, it would have 1, 3, and it would have 2, 9. So what we would have for our inverse, our parent function of log base 3 of x, it would be 1, 0, 3, 1, 9, 2. And so now we need to figure out our child points using the same strategy we've been using all year. -2 times 1 is -2, minus 1 is -3. 1/2 times 0 is 0, minus 1 is -1. Then we're going to have -2 times 3 is -6, minus 1 is -7. And then we're going to have 1/2 times 1, that's 1/2, minus 1 is going to be -1/2. And then 9 times -2 is going to be -18, minus 1 is -19. And then we have 2 times 1/2, that's 1, 1 minus 1 is 0. So we'd have the points -3, -1, and 7, -1/2, -7, -1/2. So 3, 4, 5, 6, 7, -1/2. And so we know we're going to have a vertical asymptote at x equals -1. So we draw that in right here. We make it a dashed line. And then we would just go ahead and connect our points. And so it would look something like this. Notice we can't really get -19, 0 on our graph because we don't have enough space, but we understand that that would be our x-intercept. So our domain would be -∞ to -1. And our range is again -∞ to infinity. The range for these will always be -∞ to infinity. The domain will always will have the vertical asymptote in it somewhere, either here or over here, and then the other one will either be infinity or -∞, depending on which direction the graph is going. So go ahead and work through the homework. If you have any questions, make sure you come to class on Monday with those, and we will spend some more time practicing this.